So I'm just going to introduce you to some vocabulary that we're going to be using in this video. So an element is one type of atom. And all of the elements, there are roughly 118 elements, and they're all shown on the periodic table of elements. An atom is the smallest particle of an element that can exist. Today I'm going to be talking about atoms and electron configurations. So most of the time with particle diagrams, you'll see that atoms are drawn as spheres or circles that look something like this. So this would be the particle diagram of a solid, and then a gas would look something like that. Now these particles can be either molecules or they can be atoms. So let's say that these are atoms. This would be a gas. If we took one of these particles and we zoomed into it so we could see its components, you would see that the atom is made from a central nucleus that's made up of two subatomic particles, which means smaller than the atom or inside the atom particles. Now these include the protons and the neutrons. So I'll use black to represent the neutrons and blue to represent the protons. And protons are positive. So the neutrons and the protons together form the nucleus. Now when we see an element in the periodic table, something like sodium, Na, it has an atomic number of 11 and a mass number of 23. Now the atomic number, or the proton number, is the number of protons. And the mass number, or the relative atomic mass, is the number of protons added to the number of neutrons. Now for the one that I've drawn over here, we can see that there are 6 protons and 6 neutrons. So what element is this? This element is carbon. So it has 6 protons. You can see the 6 positive subatomic particles, and if we add the 6 neutrons, we get 12, and this is where the 12 comes from. Now, this is the nucleus, but of course, orbiting around the nucleus, we have a different subatomic particle. We have the electrons. So here we have our nucleus again, and then around the nucleus we have, this can be called an electron shell. Now this can sometimes also be called an energy level or an orbital. For the convenience of this video, I'm just going to call it an electron shell. So these are electron shells, and in carbon it has 2 shells. Now carbon has 6 electrons. We know this because carbon is neutral in the periodic table. It doesn't have a positive and it doesn't have a negative. It's neutral, which means that the number of positive protons and electrons, which are negative, must be the same. So if we add these electrons, I'm going to use crosses to draw them. Carbon has 1, 2, 3, 4, 5, and 6. So this represents 1 atom of carbon. and inside carbon there are 6 protons, 6 electrons, and 6 neutrons. Now let's draw the electron configuration for a different atom. We mentioned sodium earlier, so let's draw the electron configuration for sodium. Now sodium has an atomic number of 11, which means it has 11 protons, and because there's no charge here on sodium, we know that it's a neutral, so it has the same number of electrons. So I'm going to draw the nucleus of this as the symbol, and then how many electron shells would this have? Well, it has 11 electrons, and the first electron shell, can hold a maximum of 2 electrons. That's the maximum. So let's fill those in. 1 and 2. Now, of course, there are 11 electrons in total, so we've only drawn 2, which means we have 9 left. So now let's add another electron shell. So this is our second electron shell. The second electron shell can hold a maximum of 8 electrons. So let's add those now. I like to add them at opposite ends of the electron shell. There's our 8. So now in total we have 10. But sodium, one atom of sodium has 11 electrons, which means we need a third shell. The third shell can also hold a maximum of 8 electrons. So I'm just going to put that one here at the top. And there, we've done it. We've drawn the electron configuration of a sodium atom. So if a question asked you to draw the electron configuration of a sodium atom, then you would draw something that looks like this. Now you can use dots if you want to. So the same thing with dots would look like this. But typically, if it's just one atom, then we would use crosses, but it doesn't really matter. There, so there's the same thing with dots. Now let's do one more example. The biggest atom that you would be asked to draw up to a GCSE level would be number 20 in the periodic table, which is calcium. So you would only really be expected to draw atoms up to the 20th element, which is calcium. So calcium has 20 electrons. So we have 2 in the first shell, 8 in the next shell, bring us up to a total of 10. Then another 8 in the next shell, bring us up to a total of 18, and then we need a 4th shell to hold the other 2. So this is the biggest atom that you'd be expected to draw, calcium. Now I want you to try a couple on your own, so pause the video here and draw the electron configurations of the following. Let's do hydrogen, and let's do chlorine and potassium. Okay, so pause the video here. So well done if you got these right. So hydrogen has 1 electron in 1 shell, chlorine has 17 electrons in 3 shells, and potassium has 19 electrons in 4 shells. Now, as well as drawing the electron configurations, you may be asked to write electron configurations. Now, if we were to do that for hydrogen, you'd simply put H for hydrogen and then 1, because hydrogen has 1 electron in one shell. For chlorine, you'd put the symbol for chlorine and then 2 in the first shell, comma, 8 in the next shell, comma, and then 7 in the last shell. So if we're writing the electron configuration, we're writing how many electrons are in each shell in order from inner shell to outer shell. And the last one will be calcium, 2 in the first shell, 8 in the second shell, 8 in the third shell, and then 1 in the outer shell. This is also sometimes called the valence shell. So the valence shell is the outer shell. And the valence electrons are the electrons on the outer shell. So how can we get electron configurations from the periodic table? Well, if we look at the periodic table, we see these numbers over the vertical columns. These are called groups. 1, 2, 3, 4, 5, 6, 7, and sometimes it's 8, sometimes it's 0. So these are the vertical columns in the periodic table. And then we also have periods in the periodic table. Now periods, sometimes they don't really show the numbers, but you can imagine them going down the side like this. Now it's very difficult because the first period is actually hydrogen and helium. This horizontal row is the first one. A lot of people think the first period starts from lithium, but it's actually up here with hydrogen and helium. So what do these mean in terms of electron configurations? Well, the group correlates with the number of electrons in the outer or valence shell of an atom. So if we take group 1, for example, lithium has an electron configuration of 2 and then 1 more in the outer shell, because lithium has 3 electrons. So here we can see that there is 1 valence electron. So lithium is in group 1. The rest of group 1 also have 1 electron in their outer shell. So the next one down in group 1 is sodium. Sodium also has 1 electron in its outer shell. So that's what the group number indicates. The period indicates the number of shells. So hydrogen and helium only have 1 shell. So hydrogen has 1 electron, helium has 2 electrons. As we go down in period number, the number of shells increases by 1. So the second row in the periodic table, starting from lithium, they have 2 electron shells, which we can see here. And then the next one down is period 3, which starts with sodium. Sodium has 3 electron shells. So the group number gives you the number of electrons in the outer shell of the atom, and the period number tells you the number of shells. So let's look at 2 examples of how we can use the group and period numbers to help us with our electron configurations. So we're given group 6, period 3. Now we know that the period number shows us the number of shells. So 1, 2, 3. And the group number gives us the number of valence electrons. So I can fill in the inner shells. The first shell has a maximum of 2. The second shell has a maximum of 8. And then there are 6 electrons in the outer shell. Now this atom has 16 electrons, which means it is sulfur. It's an atom of sulfur. So we have deduced just from the group and period number the identity of the atom. Let's do the same thing with the next example. Period 2 would mean 2 shells. And group 3 would mean 3 electrons in the outer shell, and all that's left is to fill in the inner shell. So 5 electrons in total means that this atom is boron. And boron has 11 as a mass number. So we've deduced the identity of the element from the group and period, and we've also drawn the electron configuration. Now we can also use the periodic table to identify an element from its electron configuration. So if we start with this one, we can see it has 2 shells, which means it's in period 2. And it has 5 valence electrons, which means it's in group 5. So then we find the element that's in period 2, so it's along here, and it's in group 5, so it's down here, and then we can see that this is nitrogen. If we look at the second example, we can see that it has 3 shells, so it's in period 3, and it has 2 valence electrons, so it's in group 2. And so we can see that period 3, group 2 is magnesium. And so we have identified this one as nitrogen and this one as an atom of magnesium.